Hello, everybody. We are back with another visual pattern challenge. So you can see here we have our visual pattern. Here's step one, here's step two, here's step three. And your challenge is to predict how many squares there are going to be in step number 4. So that's the first part of the challenge. The next part, a little more difficult, would be to predict how many of those squares in step 43 of this pattern if you continued it on. And can you write an equation that you could use to predict the number of boxes in any step of this pattern at all? So that's the challenge. If you'd like to accept it, pause the video and try it out. All right, so at first glance, this one looks a little complicated. You've got a strange shape here. It's definitely growing from step to step. I think what I want to do is just sort of draw out what the previous steps pattern is in the pattern in the next step of the pattern. So we've got this big L with 6 on top and 3 on the bottom, and that's still here, right? And it looks like all we added was 2. And then if we look at step 3, the pattern from step 2 is right there, and we've only added those 2. So at first glance, this looked a little complicated, but I think they're just adding 2 more boxes in that particular location, sort of to the right of the tail of the L there, and then shifting down one, but only adding 2 boxes per step. So this should be a pretty simple linear pattern. Let's actually plot this out just to verify what our visual intuition is telling us. So I'll put the step number and the boxes. So in step 1, what do we have? So 6, 7, 8. And in step 2, we have those 8 plus 2 more. So that's 10. And in step 3, we have 8 plus 2 more is 10, plus 2 more is 12. And I guess right now, if I were going to predict step 4, I would just make that same pattern of 2 extra boxes down there. So step 4 should look like that. And that would have 14 boxes, right? So 6, 7, 8, 9, 10, 11, 12, 13, 14. So I think we can make our prediction about step 4 having 14 of these boxes. All right. When we arrange our numbers like this in a chart, we do that so we can easily see the differences. So 10 minus 8 is 2, 12 minus 10 is 2, 14 minus 12 is 2. That goes along with what we saw. Each step differs by 2 boxes. We're adding 2 boxes every step. So this then is a linear pattern. Whenever those differences are the same from step to step, the pattern is linear. And we can go back to that old equation of a line to model it. And the m here, in y equals mx plus b, that's the slope in a line. It's going to be this rate of change in your pattern from step to step. So I'll replace the m with the 2 from our differences. So y equals 2x, x is the step number, and then the plus b, well, we'll have to figure that out. Let's try applying this equation to step 1 and see how it comes out. So what you do is you plug in the step number for x. So this is going to be y equals 2 times 1. And that would just give me 2 boxes. But I have 8. So I'm 6 short. And what that means is I have to add an additional 6. And that is our plus b. It's, in this case, b is 6. So 2x plus 6. So that's our equation. Now it works with step 1. Let's try it with step 2. Y equals 2 times step 2 plus 6. 2 times 2 would be 4, plus 6 would be 10. Yeah, that's how many boxes are there. In step 3, y equals 2 times step 3 plus 6. 2 times 3 is 6 plus 6 is 12. Yep, that's how many in step 3. So this equation seems to be working out. And we got y equals 2x plus 6. Now we can figure out how many in step 43 pretty easily. We're just going to plug in step 43 in our equation. Y equals 2 times 43 plus 6. And 2 times 43 is 86, and plus 6 would equal 92. So I think there should be 92 of these squares in step 43 of this visual pattern. Well, how did it go? Did you get that? Did you get the equation? Let me know. Thanks, everybody.